Welcome back. This is part 2 of the notes for Monday, November 16th. New theorem for today is the triangle exterior angle theorem. Before we can look at the theorem, though, we need to get a little bit of terminology out of the way. The idea of interior and exterior angles. So let's take a look. If you'll look at the diagram, I've got angles numbered from 1 through 6. Notice that 1 and 2 make a linear pair. 5 and 6 make a linear pair, and 3 and 4 make a linear pair. Okay, it's very important that you notice that those lines go straight out. We're not looking at vertical angles here. We're looking at angles that make linear pairs in the diagram. Okay, now as far as the words exterior and interior, the word exterior means outside. Interior means inside. So when we're talking about exterior angles, we're talking about angles that are outside the triangle. And they are angles that are part of the linear pair that are outside the triangle. So that would be angle 1, angle 6, and angle 4. They are angles that are part of a linear pair that are outside the triangle. The interior angles are the angles that are part of the linear pair that are inside the triangle. And notice on each of those definitions, I'm saying they are part of a linear pair. So the interior angles are angles 2, angle 3, and angle 5. They also happen to be the angles that are inside, the 3 angles that are inside the triangle. The reason I've been pushing the linear pair is when we start talking about the exterior angle theorem, we're going to look at an exterior angle that is part of a linear pair and talk about the remote interior. If something is remote, it means it's far away. So if we find angle 6, which is an exterior angle at the top of the triangle, the 2 interior angles that are the furthest away from it are angles 2 and 3. Remote being far away. Interior angles that are the furthest away. Those are called the remote interior angles to angle 6. Find angle 1. It's in your bottom left-hand corner. It is an exterior angle. The 2 remote interior angles, or the interior angles that are the furthest away from angle 1, are angle 3 and 5. Why don't you try to predict what the remote interior angles are for 4? The interior angles that are the furthest away from angle 4. Well, hopefully you saw it 2 and 5. To be able to use the triangle exterior angle theorem, it's very important that we can identify an exterior angle, one that's part of a linear pair, and its remote interior angles. And the reason it's important to us is because of what the theorem says. It says the measure of each exterior angle, angle 1 in this case, equals the sum, means you add them together, of the 2 remote interior angles. Now, I'm going to have you do the proof as part of your assignment. I think once you see the proof, it'll definitely make sense. But we're going to practice using this theorem a little bit. Angle 1 is equal to the measures of angle 2 and 3 added together. The proof of the theorem will be part of your assignment. We're just going to practice using it right now. All right, so take a look. I'm going to leave the theorem where you can see it. Here's our first example. X is, or the angle that measures x degrees. That is the exterior angle. According to the theorem, x is equal to the sum of 45 and 75. So x is equal to 120 degrees. It's a pretty handy little theorem. Saves you a lot of work in finding the measures of missing angles. All right, let's try another one. Example 2. First thing you need to do is identify the exterior angle. It's the one on the outside that is part of a linear pair. That would be the 109 degrees. Whoops, I left my 0 out. And that is equal to the sum of the two remote interior angles. The two angles inside the triangle that are the furthest away from that 109 degree angle. Well, that's the 51 and the y. And we were asked to solve for the variable, so that means let's subtract the 51 from both sides of the equation. So y is 58 on this one. They're not extremely challenging. We're just trying to make sure that you can identify interior and exterior angles. All right, one more, and then I'm going to let you practice a little bit. This one's got a little bit more to it, but it's still using the theorem. We have a few more x's flowing around, but step 1 is you identify that exterior angle. It is the angle that's part of a linear pair that is outside the triangle. So that would be the 58. And that is equal to the sum of the two remote interior angles, meaning the interior angles that are the furthest away from the triangle. So it's not this one. We want the two that are the furthest away from our 58 degrees. That would be the 3x. And the 4x minus 5. We're wanting to solve for angle D. I guess it would help if I have them lettered. Here's A. I'm going to put B out here. C and D. We'll put D over there. All right, let's combine like terms. Let's solve for x to begin with. So 58 equals 7x minus 5. Add 5 to both sides of the equation, so 63 is 7x. And divide both sides by 7. So our x is 9. We haven't answered the question yet. We've found x, but we haven't found the measure of angle D. The measure of angle D is 3x, so that would be 3 times 9, or 27 degrees. Make sure you answer the question. Okay, make sure you answer the question. All right, that's it for the examples. Use these 3 to help you through the exercises. In your homework, you're going to be asked to prove the exterior angle theorem, but I do have the guidance. I've got the statements there. You just need to come up with the reasons. And then I have 5 problems for you to work using the exterior angles theorem.